Hey, what's up? This is Corey Glenn. I'm going to show in this video how to design some custom parts in Meshmixer. The reason I'm doing this, I designed this little part to be a resin bottle drain to basically get the last drops of resin out of my 3D printer bottles, and posted it on social media and had a lot of people asking to purchase it and asking how to design it. So I'm going to do both. I'm going to put it up for sale. I'll put a link in the description of this video where you can purchase the file, but also wanted to make a video on how I actually design this, because if you can grasp these concepts of how to do some basic CAD design, then I mean really you can design any kind of part you want. If you have a problem that you can think of a solution for, then you should be able to design it. So this will partly be just a good intro course into CAD design in general in Meshmixer. So just to give you an idea of what we're going to design here, this is what I came up with. So this is a Sprint Ray DLP printer. It's got the resin tank here, and these bottles are notorious with this thick resin for, you can't get all the resin out of there. And so what I came up with is just a way that I could orient that bottle on a stand and it drain out and funnel itself into the tank, so that I can just set it up there, let it sit for 10-15 minutes, and as you can see right here, there's nothing left in there and we've gotten every last bit of resin. So, it's not like it's a huge money saver, but some of these resins are expensive and you want to be able to get the most out of them. So step one, you're going to need to figure out how you want to orient the bottle. Okay, so what I did is I just grabbed an empty bottle and I held it vertical, because I do want to stand this up vertically where I'll get the maximum drainage from all sides of that bottle. And I just set it up there, and I'm thinking, how do I avoid hitting this build plate? So basically pushed it all the way up against the build plate in a vertical fashion, and you can see I've still got that much of the bottle hanging over here. And after I took this picture, I thought, well, if I actually pull it out beyond that lip, then you could actually even start a print and be draining a resin bottle. You won't be able to close the lid, but you could actually be printing. And as long as you don't have it in a really bright room, you don't have to worry about the ambient light curing your resin just for the time where you're draining it. So this is how I want to orient the bottle, more or less. I'll probably pull this out here to the left just a little bit, where maybe the edge of this bottle is right even with this tray. And then we need to take some measurements. Okay, so I had a spare tank. I just measured the wall thickness here. So if you go back to this design, basically it just slides over the wall of the tray. And so I measured that, just took some cheap calipers, 2.6 millimeter wall thickness to your tank. And then I also need to check the height, because as you can see here, there's a limit to how deep you can go. And the measurement I got there was about 23 millimeters of available wall height. And then finally, I need to measure the bottle. Okay, so these don't have to be ultra precise. This is not a precision part or anything. So you're actually going to build in some slop space just to make this thing fit passively. So the overall bottle width of the Sprint Ray resins is 85 millimeters. I measured the distance from the top of the lid down to right here. That's about 24 millimeters. And then the width of the bottle opening, including the lid, is about 67 millimeters. Okay, so I'm rounding those up. So we'll basically go with these measurements. Okay, 87 millimeter width, 25 millimeters up to right here where it's just purely cylindrical, and 68 millimeters wide. And then one additional measurement I went back and measured was, okay, from right here where it goes from this cylindrical up to this area where it tapers out to the full bottle width. What's that? It's about a 10 millimeter tapering zone. All right, so with those dimensions, we should have everything we need now to go and start the design. Okay, so here is Meshmixer. This is a free CAD program that you can download. Even though it's free, this is a really powerful software that, I mean, I've designed all kinds of stuff in this. So don't let the fact that it's free fool you. So the first thing I want to do when I start a case, anytime I'm custom designing a part, one of the things that will make life a lot easier is for it to be based on the global positioning system of the software. Okay, so what do I mean by that? Well, if I just start the case by importing a plane, okay, this plane is oriented to what Meshmixer sees as the exact X, Y, and Z axis. Now you could kind of visualize that by going on here and showing the grid and then also showing its virtual print bed. But do you notice how that plane is exactly in the same plane as what Meshmixer sees the horizontal axis of a print bed to be? All right. Now, as we go along, I'll try to make clear why that's important, but just for the moment, just know that it is important. All right, so all we have right now is this one-dimensional plane. All right, let's check the measurements of this. I'm going to hit T for transform. Now, as I go along doing this, you're going to see me using the hotkeys because that's what's most efficient for me. But you know, you can do all of this stuff by just going, for example, to the menu under Edit, hitting transform, and we're to the same point. So what are the dimensions of this? Right now it's 25 millimeters by 25 millimeters. I want the width of this this bottle holder thing to be at least 87, 88 millimeters. So let's just go ahead and make this plane be 90 millimeters wide because that's going to give us a great reference for you know, how big all of the stuff needs to be scaled. So as I pull this little dot here, I'm stretching this shape, and you see the measurement right here changing as I do, but I can also just go in and punch in the number 90. All right, 25 millimeters, we'll just leave that width for right now. Okay, so now what I'm going to do is accept that. This gives me a basis for knowing the overall shape of things. Now, I'm going to treat this as if it is the horizontal axis, which would be the bottom of your build tank or build plate. So I need to first of all create a vertical wall that represents the wall of that tank. All right, so I'm going to duplicate this shape, and once again I'm going to hit T for transform, and this is where you'll start to notice this. So you always want to work, if you're doing it like I'm suggesting, use the worldwide frame as opposed to the local frame. I don't know a great way to explain that basically, but it's making these things operate on, again, like if I'm doing a transform movement, I don't want it to rotate in some wonky direction like this. I want to keep all these parts oriented to one another, right? So by keeping it in the world frame, I'll do that. If you're in local frame, it can get a little screwy sometimes. Okay, so let's rotate this. Now notice here, as I grab the rotation ring, I can do this in rotations to the 100th of a degree. But you also see this dial that pops up. That lets me snap to exact dimensions, okay? So I'm going to go to a 90 degree, and now I'll accept that. But we also need to think about what was the wall dimension height available. And if I remember correctly, it was 23 millimeters of available wall height. Okay, so great. I can scale this down now. I'll go T for transform, and I can stretch this. And I'm going to go a little bit less than that. I'll make it 22 millimeters. All right. And then because that's a 90 degree, I'm going to just scoot this thing up. And I don't have to be to the micron precise. You know, I can get a pretty good idea by looking up here. Since I've used all whole numbers, as I translate this in the Y dimension, and I see that I'm almost exact on that, I've got just the tiniest bit of this thing hanging down below. Chances are, if I just make this an even 11, that's going to be exactly where I need to be. Okay, so, and if I wanted to, I could pull this thing back. I'm basically mocking up the resin tank. Okay, so again, this being the horizontal, the bottom of your tank, right? As I pulled this over, if I do want to be exact, remember this was dead in the middle. It was 25 millimeters wide, so if I wanted to pull it over by half, then it would just be 12.5. And now that's a dead even 90-degree angle with both of these coming together. Okay. But beyond that, remember that this is one-dimensional shapes right now. There's no three-dimensionality to it. So what was the thickness of the wall tank, or the tank wall? It was 2.6 millimeters. Well, I want to give that a little bit of slop space. So what I'm going to do is give it a thickness of about 3 millimeters. All right, that's going to give it 2/100ths or 2/10ths of a millimeter on each side. And that should be enough to let this thing fit relatively tight, but not be, you know, difficult to adjust or get seated. Okay, so how could I give this one-dimensional object a wall thickness of 3 millimeters? Well, I could just select all. So I could either use the select tool and just select this whole thing, or I can use the hotkeys Control A. And what I want to do is extrude it. So this pop-out menu under Edit, you see Extrude. The hotkey right here is listed as D. So if I hit D, again, this is where it becomes really useful if you're working in the global framework, because it's not shooting off in some random direction. It's going to extrude outward exactly in the what would that be, the Y dimension. Okay, now how far out do I want to extrude it? Well, I can change the offsetting distance of the extrusion to 3 millimeters. All right, and now you see we have a 3 millimeter tank wall. All right, so this is giving me a reference for how I designed the remainder of these parts. Right, if you remember, again, this was 90 millimeters wide overall, so that's pretty good. We're in the ballpark. All right, now I need to mock up the bottle. So you don't have to do it the way I'm doing it. There's a zillion ways to approach this, but I'm very visual, and so I want to see that bottle in relation to this tank wall so I can position it properly. So what's the closest shape that would represent a bottle? It's probably a cylinder. So up here under Mesh Mix, you see under primitive shapes here, you've got all these random primitive shapes. One of them happens to be a cylinder. Just pull it over. Don't drop it on this shape. Drop it out in open space. Again, when you do that, that keeps it in the worldwide frame. And just so you understand what that means, you see how this is oriented perfectly perpendicular to my original plane. All right, let's look back. How wide was the lid area of the bottle? It was 68 millimeters wide and 25 millimeters tall. All right, so that's what I'm going to make the dimensions of this be. Height needs to be 25. All right, and the width, this dimension and that dimension, need to be 68. So I'll punch in those numbers so it's exact. 68. All right, and then I do want to get this just centered. I'm eyeballing this. There's ways that you could do it exact, but I'm not terribly concerned with it. So this represents the top of the bottle, where the mouth is that you would drain the resin from. So where does that need to be in relation to this wall? If you remember back to this picture, all right, remember back to this picture, we're going to basically have the outer edge of the lid be pretty much even with the wall of the resin tank. All right, so about right there. But now if I put it right there, there's no room for this to drain and to funnel into that. So I need to give it some height so that you can actually have a slope here that forces it to drain in towards the tank without taking 10 years. Okay, so I've just raised that up an arbitrary amount. You know, I'm looking at that. That looks like it would work. So that's what I'm going to go with. So I'll accept that. All right, so this is my resin tank wall. This is my bottle opening. All right, now I need to get the fatter portion of the bottle. All right, so I can do that by going to Edit, Duplicate. Let's duplicate this shape, because what that's going to do is keep this next shape perfectly concentric. All right, you see how I'm exactly in the same axis and everything. So think back to your measurements, right? You you go up 25 millimeters until you hit the tapering zone, and then that tapering zone was 25 millimeters. So if I wanted to represent the fatter portion of the bottle, I would translate that up 35 millimeters. Okay, so I'm going to punch in 35. All right, and this open space here is going to represent that tapering zone. All right, but beyond that now, I've also got to make it the right dimensions of the fatter portion of the bottle. So before I close my transform, I need to look back at what is the overall width. It's 87 millimeters. So I need to stretch it in this dimension and that dimension to be 87. All right, now is that hopefully taking shape for you? All right, and I don't have to have this be super tall because I'm not going to really wrap around the fat portion of the bottle. So I don't need to make the full length bottle. You could if you wanted to, but I don't really see the point. If you did want to just to show you another little Meshmixer trick, let's say if you did want to make this be, longer to represent the bottle and give you a better visual representation. I've used my scaling and everything to maintain these dimensions, and if I go and now transform this shape and stretch it, now I'm losing that orientation of that tapering zone. So what I'd rather do is just take this top flat edge and just extrude it upwards. Easiest way to do that is under Edit, generate some face groups. All right. Any kind of a big flat surface is going to be a single face group. I'll select that and hit D for extrude, and I can just extrude that up. I don't know how tall the bottle is, but let's just say it's, 90 millimeters. Okay. So now you have something a little bit more representative of a bottle. All right. What I want to do right now is make this solid. Okay, so the only reason I'm making it solid is that that's going to give me a much greater mesh density. I could remesh it, but honestly the quicker way is just to make solid. So let's go to Edit, Make Solid, and I'm going to change this from fast solid type to sharp edge preservation. I want to maintain those crisp lines right here, and I'm going to bump up the solid accuracy and update it. All right, so there we have our shape. And now I'm going to do the generate face groups. Okay, so when I accept that, do you see that this is all a face group I can select, and this is all a face group I can select? And that's useful to me because I'm going to just delete them. All right, so one of the features in Meshmixer is if you've got an open boundary to a mesh, I just hit W for turning on the wireframe so I can see these edge triangles. If you double click on an open area of mesh right on the boundary, like right on one of the edge triangles of that open boundary, then what it's going to do is select the entire boundary all the way around. So I'm going to do that on both. And now I can just hit J, which is join. And I have more or less a tapering zone. Now, is it exact? No. If you look back at this shape, this is a more rounded shape, and there's ways I could do that, but it's not worth the effort. Remember, I'm going to build in enough slop space around this that I don't have to have this exact. So now we have my bottle oriented correctly to my tank wall. All right. So now we get to start designing the part. That was all just kind of preliminary to, you know, just to generate a shape here. Okay, so now that we got the tank wall and the bottle represented, okay, now that we've got the tank wall and the bottle mocked up in the right positions relative to one another, what I want to do next is make the little mechanism that's going to slide over this tank wall to hold this. So let's look back at this and get an idea for it. Now, this should be designed to just hold a nearly empty bottle, but occasionally someone might put one that's got a higher amount of resin in it. Maybe it's a half full bottle that they're draining. So it needs to support a little bit of weight. And because this is basically what's supporting it all, I want to make these walls right here that you're seeing thick enough that they can resist that force on that if you have a heavier bottle. So I don't remember what I did when I did this. I'm probably not even going to use the exact same method to design this because I don't even remember how I did it. But I would say this having a 4 millimeter wall thickness should be plenty strong enough that we can support even a full bottle. Okay, so let's try to do that. The way I'm going to do that is, first of all, let's duplicate this shape, edit, duplicate, and I want to add 4 millimeters this way and 4 millimeters this way. So that duplicate, let's hit transform. Currently the width in the Z dimension is 3 millimeters. So what if I added 4 millimeters to either side? That would make this be 11 millimeters. Oh, okay. So right there, it wants to jump off just in a single direction. So let's actually backtrack on that. All right, I turned off the tank wall, and this is the duplicate of it. So if I wanted to maybe come off exactly or 4 this way and 4 that way, again, let's go back to generate face groups. Those are sharp edges. We're going to get a single face group here. Let's click this one and that one and hit D, that's extrude, and let's give it 4 millimeters of thickness. Okay, and then I'll accept that. I would say probably we need also 4 millimeters of height above here as well. So even after I've generated face groups, I can just come do it again. Now, again, this is all flat, so I can extrude this up D by 4 millimeters and accept that. All right. Now, I don't need this thing to be the full width of the wide part of the bottle, because remember, it's only draining out of this lid here. So I'm going to hit T for transform, and I'm going to scale this down. Oops, I need to control all and then transform that. Actually, since I'm doing it with a selection, it's not giving me exact measurements, so don't select anything, just hit T for transform. Now I can see this overall shape. And if I remember right, this was like 68 millimeters. Let's just make it an even 70. All right. And now if you turn back on your tank wall, you can see how this thing is oriented to the other. All right. So at this point, I always want to have a representative tank wall here to visualize. So I'm going to duplicate this right now and hide one of them so that I've just got that as a reference to go back to. You could save all these parts as you go along, but I would just say don't export them or anything. It would be wise to save your case. Let's do that real quick. I'll just save it in my documents and call this bottle holder project. And that way, at any point, after every step I've done, I could just hit Control S, it'll save the case, and if I have a crash or something, I can get back to it. Okay? So I've got this shape. I want to first of all make it solid, because what we're going to do is we're going to Boolean subtract this shape from this shape, right? And that's going to give us our holder. All right. When you're doing Boolean functions don't operate great with these, very big meshes and sharp angles. So I'm going to make this solid, and then do the Boolean. All right, so let's make solid. I'll just accept the fast version. And now let's take this one and make solid. Accept that. All right. Now the one thing that could be problematic is, and I'm going to Control S in case this crashes, but this is a good learning opportunity. What if I just take this shape and subtract it from this shape? Now, mind you, if I look at the bottom, these basically share the exact same bottom edge. All right, watch what happens when I attempt that. So this, control select that, the object you want to subtract, and do Boolean difference. All right, now I'm actually surprised it worked, but it didn't work completely, right? Because those meshes were so similar, it doesn't know how to subdivide up those triangles. So let's cancel that. I could fix this by just taking, well, easiest thing, let's just transform this. Again, this is not a precision part. What if I just scoot this up? I mean, even like a tenth of a millimeter. Now that thing is cleanly shining through the bottom of it. And so now when I do that Boolean subtraction, I should have a really good result. There we go. All right, that is going to be my lip that supports this whole thing. And as I go along, I'm constantly looking back and referencing, do I think, because I've added some height here, maybe I'll scoot this up just a tiny bit more to give it a little more running room for gravity to do its thing and drain this bottle. Just eyeballing it. And now I can start to create the supporting structure for this bottle. All right. So this is relatively representative of that bottle. All right. So what I'm going to do is I'm going to offset this shape. Okay, so Control A, and again, I want it to have a little slop space in there to support this thing. So I'm going to offset this by, let's just give it, 1.5 millimeters. Okay, so when you do your offset initially, it's going to go back to whatever the last time you used the offset function, it's going to use that measurement. I need to change my offset distance to 1.5 and then hit enter, let it refigure. Okay, so now it's offset that by 1.5 millimeters. Now watch as I accept this. When I hit accept, this is that newly offset surface, and it's still selected orange, which is helpful for us because we need to separate that off. All right, we don't want it to be one and the same STL as the bottle. So while it's still selected, you could either come to edit and, modify. No, where is it? Oh, it is under edit. Separate, or you can just hit the hotkey Y. All right, now you see there's my original bottle. Here's my offset bottle. Original bottle, offset bottle. It's just 1.5 millimeters larger. Okay, so I'm going to turn off the original bottle, and now this, if I was to to look inside of this, it's the exact same bottle shape, just offset 1.5. But now I need to give it some thickness. All right, how much thickness do I want? This doesn't have to be quite as thick, so I would probably just do this by maybe clicking Control A to select it all, and let's offset it again, but this time let's choose 3 millimeters. All right, again, it defaulted back to 1.5. Let's this time make it 3. Click somewhere and let it refigure. All right, there's 3 millimeters. I'm going to accept it. Now, once again, while this is still selected orange, I want to separate that off because I want to show you something that will probably cause you some issues if you're not aware of it. Prior to separating this, I had the inner shape, and now I've got an outer shape to give this all a 3 millimeter wall thickness. But the problem with that is, if I turn this one off, both of these meshes are facing outward. All right. And in this scenario, I actually need this shape, Control A, to face inward. So I can just select it all and say flip normals. All right. That makes it this candy cane striped color, right? Because now, I wonder if I can go internal here. Yep. Okay, you see how now the mesh is facing inward. That's what I'm after. All right. So I've got this mesh facing inward. I've got this mesh facing outward. Now I can recombine them. Now I could have done that with just selecting, but this is just a cleaner way to do it. Let's combine those back again. Now I have this outer shape, which is 3 millimeters larger, facing outward, and I've got the smaller shape facing inward. And the reason that's important is because let's now do a plane cut and see what this looks like. Once again, the value in being in the worldwide frame, when I do functions like plane cut, everything is oriented. You see how this is a dead perpendicular cut? And I want to discard the upper half. All right. If I hadn't done that where I flipped this internal surface inside out, then all of this internal here would be that candy cane striped color because the mesh is flipped 180 degrees from what it should be. This is actually a solid part. It's got an internal surface and an external surface, so you need to have those meshes facing the right way. All right. I don't need this closed bottom on here, so I'm going to do a second plane cut. But this time I'm going to come down and discard right here. This is the bottle holder taking shape. So I'm going to scoot this down as far as I can. Oops, right there. You see I'm back into this portion where it's still solid. And if you have it solid, it will just fully close this like that. I don't want that. I want a fully open bottom to this. So I'm going to just cut that off right there and I'll accept it. Okay. So think of this as your bottle holder. Now, again, earlier I extruded this thing way up, and that's created a lot of unnecessary computing power because you've got a much bigger surface to offset and things like that. So I'm going to go ahead and chop this thing down to size. I don't need to hold more than about maybe to right there on this fatter portion of the bottle. It's not going to get out. It's standing straight up vertical, so let's just cut it off there. So one more time, plane cut. Let's flip the direction that we're going to discard. And again, I'll just eyeball it. That looks pretty good. And just as a double check, you can always turn back on your original bottle. Wherever that was, there. This is your original bottle, and you can see how this thing is going to fit in there with 1.5 millimeters of extra spacing on either side of it. Right? That's what we were trying to accomplish. So we've got the portion right here that is going to grab onto the edge of the tank. We've got the bottle stand, but they're not connected, right? And I need a funnel type shape to let this thing pull itself down and let gravity drain into this. Now, as I'm looking at this, I'm still thinking I would like a little bit more of an angle. But I also want to preserve my orientation. So I could just say transform and pull this up, but now I've lost my orientation of the bottle. All right. If I was to control select both of them and push T for transform, I can move them together. All right. So I'm just scooting them up just a tiny bit. You can see this for a non-precision part, there's a lot of just eyeballing it, guesstimation, that kind of thing. That's all good. All right, so now we need to create the tapering funnel portion that's going to come down in here and connect to this. So I actually don't remember exactly how I did this on my original design, so we're going to wing it and just figure it out as we go. All right, so right now where I did that plane cut, this is all a single face group. All right, what would happen if we tried to soft transform this? And I don't know. Let's see. All right, that's not going to work because you see how it's pulling this with it. Can't do that. So I want to more or less leave this purple section untouched and unaltered. So instead, I'm going to just go to D for extrude, and I'm going to extrude a big chunk off of this. Once again, because I'm in the worldwide frame, my extrusion happens directly down in the Z dimension or whatever that is. All right, doesn't matter really the distance, but I'll just put in an even number. All right, that's useful that it's just made this into a new face group. Now watch what happens here. Once again, if I go to soft transform, what soft transform does is it transforms it, but it blends it. It makes it nice, smooth transitions. And again, the way it's going to do that is if you've got a full selection here and you go to soft transform, watch how much more it actually is going to pull from. All right, it's pulling from all the way up here. I don't want to do that. All right, so I'm going to do some guesswork here. I want to scale down this area of my selection. All right, so you could do this under modify, contract ring. Watch what happens when I contract this ring. Modify, and I'm going to turn on the wireframe where you can see it. Contract ring. See how I just pulled it back one triangle in all dimensions? And the hotkey for that is shift, hold shift, and then click your left or your less than sign. And I'm going to go down to maybe halfway on this and then just give it a try and see what happens. All right. Now while I've got that, I'm going to hit Control G, make a new face group so that now it can just be clicked on. All right, let's do this. Let's select that whole face group and once again go to soft transform. And what I want to do is, remember, the purple I want untouched, and that's perfect. I can't believe I guessed that exactly, because I figured it would roll up onto the purple a little bit, but it went right to the boundary. So I lucked out there. If I had seen that my selection now for soft transform goes up into the purple, I would cancel it. I would, scale my selection down, contract this ring a few more times until when I go to soft transform, it's going to leave this purple untouched in the selection. All right, but since that nailed it, let's just go with it. Soft transform. And now what I can do is pull this thing off and create my tapering funnel zone. Actually, I'm going to Control Z that. I was pulling on that triangle area, and really probably what I ought to do is use the arrows so that I keep it in the same plane as my my little tank holder lip. And I'm going to just pull this thing down until I'm roughly in the same dimensions. And I'm trying to look inside here. I want to make this a smooth edge to roll off of. Maybe like that. Okay. And I'm going to accept that. All right, so my bottle holder is still fully intact, nothing altered about it. I don't need to see that. And ultimately, I'm going to need to merge these two shapes. So I need to start modifying it before I do that merge. So let's now plane cut. Now watch what happens here when I plane cut. Right now my default plane cut is going to be exactly 90 degrees, but I want to plane cut this way. Again, on the dial, go to 90 degrees from that. All right. So let's pull this over because I do want these parts to touch. And you can see that they are touching there. Depending on how much work you want to do with this, you could go with that shape. That actually works. But what I was going to show you is when you do a plane cut, it's going to cut indefinitely through all parts of your shape that you've generated. What if I don't want to do that? All right, what if I want to leave this fully intact? Well, then instead I could just, grab all of these. I've just selected an area of some of this brown and that green. But now if I hit G, that's expand my selection to everything of that group. All right, and you can see where that selects to. Now, I've got something selected now under Edit, let's plane cut. And this plane cut will only affect what I have selected. Once again, 90 degrees. And I want to come out just beyond. See that little bit of daylight there? And I'm going to accept that. All right. I also don't need any of this portion. So let's go to Edit, Plane Cut. Now this one, I don't care if it cuts indefinitely through it. So I'm going to, oops, let's undo that. This is in the right dimension. I just need to pull it down. So I'm looking at it. And again, don't have to be precise. I actually do want it to go just a little bit beyond that edge. So I'm going to accept that. All right, now you have a nice funnel shape. Okay. However, with that said, you see that the stress point in this is going to be right there. You've got a sharp angle. You've got no support connecting up from here to here. And so how could I remedy that? Well, let's think for a moment. I could, okay, I know what I'm gonna do. I had to sit there and think for a minute because I'm just making this stuff up on the fly. I don't really know what I'm doing. I wonder if I just hit T for transform and just pulled this straight down. I mean, again, this doesn't have to be super pretty. That could work. If you remember, I was just trying to basically bridge this gap in here. All right, so I could do this, and as I'm working through this, I'm deciding there's an easier way to do this. So know that this is one option. I'm going to cancel that, and what I'm going to do is instead, I'm going to delete this selection that I've got here. Oh, I'm sorry, not delete it. I want to keep that selection. And now on this one, I want to select roughly the same area. So this time on my tank holder thingy, I'm selecting this. I don't want to alter that edge any. And let's create a face group. I'm going to smooth it. And now let's combine these two shapes. So what would happen if I selected all of this group and all of that group? And let's just try this. I don't know for sure if it'll work, but let's go to Edit, Tube Handle. Now I don't know why they call this tube handle because it's kind of a goofy description of it. But that more or less accomplished what I was after. I don't love this little rough edge here, but again, how picky are we trying to be here? If I wanted to, I could smooth that up with maybe a robust smooth tool. Just to give it a little cleaner transition. And I could even run around this whole border, smoothing that up. Okay. I could alternatively, that makes a new face group, and I could expand this out, right? So it's rolling beyond that selection. and I could just smooth it all. I can increase the smoothing scale to make it even more smooth. All right, you get the idea? So there we go. So you could stop here and you could just export this shape, print it, and this will be a funnel. Now, anything I say beyond here is optional because this would work perfectly functional. But if you look back at my original design, it's got this opening. And the reason I did that is I was thinking, well, even once you drain it, you might have, some resin that's just sitting here and you want to scrape that out. As between uses, you're going to wash that off in some alcohol, and you want to get in there to, wipe out any, uncured resin that's on this. So I wanted to have access into there. So let's just talk about how maybe we could fix that. Um, I'm going to go and just grab another cylinder. All right. Actually, you know what? Let's undo that. It'd be even easier if I had a cylinder that was already oriented to this. Well, it just so happens I do have that. I've got this, remember? This was, when you made solid, this was still the original primitive shape, okay? I always want to keep that, so I'm going to duplicate it and just work with this one. Remember, this was the lid area and the bottle. I'm going to select just that and then invert and delete that portion. And what I'm doing is I'm just creating a shape that I can Boolean subtract from this to make that opening. So, and this will keep it all concentric again. So that I like. And maybe I can even go a tiny bit fatter. And eyeballing everything. I'm going to make it a little bit smaller. Okay. And then how high up do I want to subtract? Let's just extrude this guy up. I'm going to punch in 25. All right. Remember, it's a primitive shape, big mesh. Let's make it solid, which again preserves my original shape up here in the objects browser. That's one of the reasons I like to do it that way. Make solid. All right, the other is still present, it's just hidden. So let's just see what this would look like if I subtracted that. And maybe I make some changes, maybe I don't. That's pretty clean. I don't know that I would change anything about that. Only thing I'd probably even consider is maybe stretching it back more to make this even more open. And I could do that actually by stretching the shape. Let's see what that would look like. Okay, so I actually like that bigger opening, but it created a new problem right there. So how could I address that? Let's cancel that so it doesn't apply it. Another trick, you can use these shaders. That lets me see internally what's going on. So if I didn't want to cut away that, I could just plain cut this. And I'm going to just spin this to roughly parallel with the bottom of that. And let's try it now. Okay, so I'm going to turn back on the regular shader. This one, subtract that one, Boolean difference. I like it. All right, you can see I barely clipped right there and created a little subtraction, but that's so close that I'm not gonna alter that. Instead, what I could do is whenever you do those Booleans, it's going to create a face group. And so I could, since that's a bunch of different colors, right? I could select this and say invert and create a face group. That's Control G. And now that just lets me double click this, double click that, and now I could go to Edit, Erase and Fill, or hotkey F. It just erases that mesh and does a straight fill in over it. All right. So I like all of this. I don't want to alter anything. You do see these little red dots. That's indicating imperfections or holes in the mesh. I can fix that just by using the inspector, fixing them all. All right. We could absolutely stop. We could have stopped a long time ago, but again, why not just, make this a learning opportunity for you. The only thing I'm looking at that I would maybe want to change is that this portion right here has these striations. It's not the smoothest. I could smooth that by hand, of course, but what if we just made this all smoother to start with and minimized our post-processing? So I can do that by going to select here through here. Again, I want to maintain the shape of that portion that is going to hold the bottle. And just select this. All right. And what if I just went to smooth? All right. That looks great, except for it did something kind of goofy right here, which I don't understand. Let's cancel it and just see. Maybe it wouldn't do that. Oops. I do want to go back. I want to create a face group so I don't have to do that again. And let's just maybe touch this real quick with a smooth tool and see if we don't get that goofy spike off here. All right, not a really aggressive smooth tool. Let's select the group again. I smoothed it, and let's go to smooth. Now, why'd that work? I don't really know. I just know from experience that whenever I have a spike somewhere, usually it's that there was a weird angle to the triangles and it just did something strange. So I could definitely go with that. While I got this selected, I'm thinking now, let's minimize how much resin we use. So under Edit, again, if I use plane cut under Edit when I've got a selection, I could just plane cut this blue portion. And actually, let me cancel that. I keep doing this manually when I should be doing it with this thing so that I keep my plane cut symmetric. What about that? All right. We just saved about a nickel worth of resin right there just in the printing of this overall thing. Just trying to think if there's anything else I might consider doing. I could maybe smooth all of this exterior shape a little bit, but I mean, what's the point there? I think I'd go with this. This is good enough. You've got enough room for gravity to drain this. You've got good open access to get in here and clean this out. And you're probably tired of watching this video. So I think I'd stop with that. So if you want to design your own, you can absolutely do it. This is the technique I used for making my other. I know this is slightly different, but it's the same general process. Or if you would prefer it, you can just buy the one I've already designed. But then you lose out on all the fun opportunities to learn. Oh, I did think of one other thing. All right. When I was looking at this shape, I thought, the weak point is right here. Now I made this one thicker, so I don't think you would even have to do this. But in my original design, if you look at it, I added this strut here to give it a little more support connecting that. Let's just do that for the heck of it. So a lot of ways you could do it. You could select an area. So what if I just grabbed a selection like right there, and right there, smooth them, and then push tube handle. I could do that. All right. But because that's at an angle, it kind of isn't the strongest there. So what I'll do instead, and what I did on my original one, is just add tube. All right. When you add a tube, you're going to see two red dots on the ends of the tube. All right. Grab those red dots, move them where you want. So I'm going to start by just trying to get this symmetric and roughly in the middle. But now that tube's too thin to do anything. So what kind of a radius do you want this to have? What if we went 4 and 4? You can change the radius on each end. And then do you want it to append or do you want it to Boolean right here? One of the things when you use the add tube features, sometimes you'll get a little extension off of this, in which case it's better to create a separate object, new object, and that way you can just plane cut the ends of this into the interior of this portion and that portion. But here I don't see anything poking through, so I'm going to just say Boolean and accept it. All right. See, it did it here. And now, because this thing poked through, it's not like I can just select that, because this is all one mesh. All right, this is all one water type mesh. But what I can do is just select that group and that group, G, F, erase and fill. It's a pretty easy fix, but if I'd have done it as a create a new object, then that portion that was poking up, I could have plane cut, and then when they're not impinging through each other's functioning surfaces, then I could come back and do a Boolean union. So that's it. I'm quitting with that. Hope you enjoyed that rare look into my semi-autistic brain. Thanks.